Hi, welcome to the KB6NU Tech Class. I'm Dan Romanchik, KB6NU, author of the No Nonsense Amateur Radio License Study Guides. This is lesson number 2 in my online tech class. Today we're going to talk about power and decibels. The term that describes the rate at which electrical energy is used or generated is power. Electrical power is measured in watts. The letter W is the symbol we use for watts. The formula used to calculate electrical power in a DC circuit is power P equals voltage E multiplied by current I, or P equals E times I. Let's look at a couple examples. 138 watts is the power being used in a circuit when the applied voltage is 13.8 volts DC and the current is 10 amperes. Let's see how we get that. Well, we said P equals E times I, or 13.8 volts times 10 amps, and that equals 138 watts. Let's look at a second example now. When the applied voltage in a circuit is 12 volts DC and the current is 2.5 amperes, the power being used is 30 watts. So in this case, P equals E times I, which translates to 12 volts times 2.5 amperes, and that equals 30 watts. Just as with Ohm's law, you can use algebra to come up with other forms of this equation to calculate the voltage if you know the power and the current, or to calculate the current if you know the power and the voltage. The formula to calculate the current if you know the power and the voltage is I equals P divided by E. Let's look at an example. 10 amperes are flowing in a circuit when the applied voltage is 12 volts DC and the load is 120 watts. So in this case, we're using the word load to mean the power being consumed by the circuit. So our equation is I equals P divided by E, and in this case that's 120 watts divided by 12 volts, so the current is equal to 10 amperes. When dealing with ratios, especially power ratios, we often use decibels, or dB. The reason for this is that the decibel scale is a logarithmic scale, meaning that we can talk about large ratios with relatively small numbers. When the value is positive, it means that there is a power increase. When the value is negative, it means that there is a power decrease. At this point, you don't need to know the formula used to calculate the ratio in dB, but you do need to keep in mind the following values. 3 dB is the approximate amount of change measured in decibels, dB, of a power increase from 5 watts to 10 watts. 5 watts to 10 watts is a ratio of 2 to 1, and because it's a power increase, the value is positive. Minus 6 dB is the approximate amount of change measured in decibels, dB, of a power decrease from 12 watts to 3 watts. 12 watts to 3 watts is a ratio of 4 to 1, and because it's a power decrease, the value is negative. 10 dB is the approximate amount of change measured in decibels, dB, of a power increase from 20 watts to 200 watts. 20 watts to 200 watts is a ratio of 10 to 1, and because it's a power increase, the value is positive. You can interpolate between these values if you're given a value that's not one of these. For example, if you're given a value of 7 dB, well, you know it's between 6 dB and 10 dB, so it's got to be a ratio between 4 to 1 and 10 to 1. And in actuality, it's about a 5 to 1 ratio. And you can do this with other values as well. Well, that's all for today. Thanks for attending the KB6NU Tech Class, and I hope to see you again.